So now let's look at some example problems involving friction. Here's the first one. Let's say I'm pulling a box across the floor with mass 1 kilogram, and I am pulling at it with a force of 15 newtons across the floor. The floor does have friction with some coefficient of kinetic friction, and it's kinetic because we have an object that's moving. And this object is moving at a constant speed of 5 meters per second. And what I want to know is, what is that coefficient of kinetic friction between the surface and the box? So before we do anything, at the end of the day, this is a force problem, right? We should be making a free body diagram. I already included one force, it's 15 newtons. We're also going to have a force of gravity. I'm going to actually redraw it down here. So here's my force. I have a 15 Newton force acting on it to the right. I have gravity pointing straight down, and I'm going to call that mg. I then have a normal force pointing straight up. And then I have the force of friction. And if we remember which way friction points, especially if it's kinetic, friction is always going to try and oppose motion. It's going to try and slow the object down, which is why friction in this case is going to be pointing to the left, since the object is moving to the right. Its velocity. Okay, so I'm going to call it Fk for kinetic friction. And now the next step would be to do a sum of forces equation. And regardless of whether, you may be thinking, hey, how does that help us find mu k? Just calm down, masses, okay? I just want to follow the physics rules, and the physics rules clearly state the first step of any force problem is to make a free body diagram and then write your sum of forces equation. In this case, it's F net in the x or y direction. You can choose either x or y. I'm going to choose x because friction is showing up in the x direction, and ultimately that's what the question is asking about. So F net x, all the forces to the right, 15, minus the forces to the left, Fk, minus Fk. And that equals mass times acceleration. Mass times acceleration. One thing we can say is, do we know the acceleration in the x direction? I really want you guys to think about that. We have a box moving at a constant speed of 5 meters per second. If you see 5 meters per second and you realize, oh, that's the velocity, right? And then you can start using kinematics and plugging in time and distance, and you'll quickly realize, wait a minute, I don't know time or distance. I also don't know if this is the initial or the final velocity of 5 meters per second. But if you really think about what's going on here, the answer has nothing to do with the fact that this is moving at 5 meters per second. It all has to do with the fact that this is a constant speed. And what does constant speed mean? Constant speed means that the acceleration is 0. That whole thing is 0. Okay? In other words, 15 newtons is equal to my force of kinetic friction. That's pretty cool. But how does that help me solve for mu k? Well, remember, we have an equation that involves mu k, and that is the frictional force, Fk, is always equal to mu k, the coefficient of kinetic friction, times the normal force. And now let's think about it. We have Fk, it's 15. We're solving for this. If we have the normal force, we're good to go. Do we have the normal force? No. Is there an equation for the normal force? Not an equation that we can use every time, but if you remember the way we normally find normal force, it involves F net in the y direction, and the reason for that is because if we look at the two forces here, mg and Fn, they're both in the y direction. I have a question for you guys. What's the acceleration in the y direction? Is it moving up or down? No. The acceleration is 0. And if the acceleration is 0, then it means that mg and Fn have to equal each other in order to cancel each other out. What I'm trying to say here is that the normal force, just like it so often does, is equal to mg. And that's because the acceleration is 0 and there's no other forces acting in the y direction besides these two. Okay? Following along with me so far? Good. So now let's start plugging in. Oh, we didn't even find mg yet. Mass was 1, right? So 1, we can assume G is 10 because I am lazy, and even though I have a calculator right here, you better believe I am not plugging in 9.8 when I can just use 10. So we have Fk is 15 equals mu k times normal force, which is 10. Therefore, mu k is equal to 15 divided by 10, which is 1.5. Just so you know, that is an incredibly high coefficient of friction. And the reason that it was so high is because I chose a very small mass, is I guess really why it came down to that. Okay? So that's the coefficient of kinetic friction. It's the correct answer, I promise. And again, to reiterate the steps, the first step of any force problem is to write the free body diagram. Second step, sum of forces equation. Third step, solve for whatever. And the whatever here was mu k, which means we needed the equation for kinetic friction. And from there, we were good to go. Thank you all for watching this video. For more tips and tricks and physics help, visit www.danwtutor. I'll put it on the screen. And then my email is danw.tutor@gmail.com. So thank you all for watching, and I'll see you next time. Bye.